The leaves are peaking in color, marathon season's over, there's a chill in the air, and it's time to start looking at what's coming up in the upcoming winter. This is my 2025 to 26 Willamette Valley winter weather predictions, and the only thing I'm guaranteeing this winter is that it is going to be a Rickroll-free presentation. I'm meteorologist Tannis Leach, and this is going to be my technical version. This is the same presentation that I presented at the winter weather forecast conference on the third Saturday in October. If you just want the predictions, that will be a separate video. I do have one thing to update on my scorecard that I posted back in April, and that is because of the dry spring, it has come out to be a forecast miss for the water year total. Nothing else has changed in that regards. If you want to see the details of why I graded everything the way I did, please check out that video that I posted in early April. Now, my annual disclaimer. This is long range forecast is intended to provide general sense of what may happen in the upcoming months. It is not a this is for sure happening, nor is an excuse for you not to be prepared for any extreme weather events. All right, now that that's out of the way, let's go on to my methodology for anyone who's new here. I do an adjusted analog year approach using ENSO via the Oceanic Nino Index, confirming it using the Southern Oscillation Index. I also use the Pacific Decadal Oscillation. I am still not using the Atlantic Multi-Decadal Oscillation like I did in my earlier years, since that data set is still not being updated. I also use the quasi-biannual index, also known as the QBO for quasi-biannual oscillation, the sunspot count, and one thing to note is that analog years are not weighted equally. Analogs that are closer to this year's condition-wise will have a higher weighting. Adjustments to analog years can be made using statistical analysis, and I use that if there is a statistically likely or unlikely chance to find as 90% or greater something occurring. But if analog years show the opposite, I'll completely disregard it. Analog years have the higher weighting in this case. General trends based on previous seasons will also be used when appropriate. All forecasts will cover what has happened in one out of every 3 winters at the Portland airport. Secondly, adjustments to past data. Snow prior to the 1970s have been adjusted to a 4.3-inch average per winter on analogs. Further adjustments can be made if necessary for marginal snow status because on average, our temperatures are about 2 degrees warmer than it was in the early 1900s. So that 33-degree snow that happened in 1910 may not happen today, for example. Temperature departures have been adjusted to the averages at the time of which they occurred. And because PDX data only goes back to 1940, I use downtown Portland prior to 1940. So as a result, I've adjusted the precipitation totals to get to a PDX equivalent, which is 83.8% of what downtown gets. Eugene goes back to 1892. However, the first couple years it is a little bit spotty, so I generally start Eugene's data at about 1900 as a result. Right, let's move on to our data and oscillations. First up, we have the ENSO 3.4 index. You may have heard through news sources that it's looking like we could be going into a La Nina winter. Not so fast. This is the 7 models that I like to use, and for reference, you need 5 consecutive 3-month averages at half a degree Celsius or colder for it to be considered a La Nina. This is the coldest average that I could find, and I like using these 7 models because in the 6 years that I have done this, I have found that the overall average has come out within a tenth of a degree of the actual total for coldest 3-month period compared to the coldest 3-month period. So I'm going to keep using that. Minus zero point 0.6 is not safely in the La Nina territory. It very well could be what we experienced last winter, where we are officially ENSO neutral, and just briefly dip into La Nina conditions. That is what I am favoring this winter. So, and then also two of these models, the Australian Bureau of Meteorology and the Euro model, are pretty much saying we're starting to warm up in the next month or so. The rest of these are saying that we're either going to hold what we're currently at, which is right at about 4/10 of a degree Celsius below average, or in some of the cases with the UK Meteorological Office and the France Meteorological Office leading the way, is that we'll cool down a little bit more into La Nina territory. So, because of that, I do need to bring up this that I've brought up every year, and that is that the closer you are to ENSO neutral, the larger the risk is for major windstorms. In the Pacific Northwest, every major windstorm has occurred in either ENSO neutral or a weak El Nino or a weak La Nina, with it being slightly more favored in weak La Nina compared to a weak El Nino. So this could be a danger zone year for a major windstorm, depending on what the analog years show. In terms of what happens during these ENSO states, for ENSO neutral, the median snowfall is about 2.6 inches, which is slightly below our long range median of 3 inches. Average temperature or median lowest temperature are both near the long term medians. The water year rainfall median is about 4.5 inches below average, which is 37 inches at PDX, and typical mountain snowfall. Weak La Ninas is the snowiest ENSO state with a median of 7.3 inches. Average temperature is about 2/3 of a degree below average. Median lowest temperature of 17 degrees compared to a long-term average of 20. The water year rainfall median averages about 1.5 inches above the long-term average. However, the driest water year was in a weak La Nina. And mountain snowfall typically averages about 115%, though there have been weak La Ninas that have pretty poor mountain snowfall years. Southern Oscillation Index the last 2.5 years. Generally, if it is in the positive phase, that favors more La Nina-like conditions. If it's in the negative phase, that shows more El Nino-like conditions. It's showing we're not quite in the positive phase yet, but it has been leaning that way. I do expect that that is going to be leaning more towards positive as we go closer into the winter months, though maybe not as far as last winter. The Pacific Decadal Oscillation is firmly negative, coming off of a record low PDO back in July of this year. The one thing I do want to touch on is the sea surface temperatures. In the north central Pacific, we have what is called the blob of warmer than normal sea surface temperatures. That's up to 5 degrees Celsius above normal. Now, the PDO, this isn't necessarily a classic PDO signature because the waters off our coast are a little bit above normal, though some colder than normal temperatures are starting to pop in. Normally, a negative phase of PDO has a cold ring around a warmer than normal temperatures in the north central Pacific. You can also see the La Nina conditions developing in the tropical central Pacific as well. But the blob does not look like it's going to sustain itself in the northwestern Pacific as sea surface temperatures are cooling off over there compared to average. But in the north central Pacific, it is looking like it's warming up a little bit. And immediately off our coast, it is cooling off. So that does tell me that the PDO might go a little bit further into the negative phase is as a result, but it might take a month or two for it to fully respond to that. And the reason why the ENSO area is looking the way it is because a lot of times when you're getting these developing El Ninos or La Ninas, it'll go out in waves. So that's why it's looking like, oh, there's below normal here, but above normal right behind it in its wake. So It's doing everything as it's supposed to. QBO values, we have flipped into the easterly phase. We are pretty firmly in that, looking at the upper level pressure and mean zonal winds. And sunspot count, we are now past the solar maximum officially, though we are still pretty close to that. Then, taking a look at our analog years and statistics, one of the few things that went well this past year was the fact that I put most of my analog years in that ENSO neutral year or a weak La Nina rather than putting all my eggs into the La Nina basket. I am going to do the same thing this year, and about half of these are ENSO neutral, half of these are in that weak La Nina category. 5 of these are going to be my top analog years this winter: 1893 to 94, 1921 to 22, 1967 to 68, 2013-14, and 2017 to 18. Last year, the best analog year was the oldest analog year. Will that happen again this year? We'll find out in about 4 months. Taking a look at the oldest two analog years first compared to what I'm expecting this year. 1893 to 94 was a weak La Nina, with the PDO being negative with a blip actually on both of these years. 1893 to 94 sunspot progression was actually pretty close to what we're experiencing this year, with it being about 60% through the solar cycle, versus 1922 to 23, where it was approaching the solar minimum. But the ENSO strength was closer to what we are experiencing this year. And one thing you might ask is, ENSO data only goes back to 1950. Before 1950, I used what's called the Ensemble Oceanic Index, which I will link in the description below for anyone who wants to take a look at that specific data set. That data goes all the way back to 1850 and reconstructs ENSO data even past 1950, so there's one consistent methodology for everything. Taking a look at the other top 5 years, 1967 to 68 was another one of these borderline years that was super cold neutral or a weak La Nina, depending on who you ask. PDO negative with a blip in there. QBO was in the easterly phase. QBO data starts around 1952 to 53. Sunspot progression was on the other side of the solar maximum. 2013-14 was the colder side of a neutral. PDO was negative to start, though it did deteriorate as we went throughout the winter, and it flipped into the positive phase the summer afterwards. I kept this on here because this had the best match in terms of the sea surface temperatures, including in a developing blob out in the north central Pacific. The QBO was easterly to start. It did flip into the westerly phase later on, however, and the sunspot progression again was a little bit before the solar maximum. 2017 to 18 was on that weak moderate borderline. PDO was in the negative phase. It did have a better sea surface temperature match in terms of a blob, as one was just starting to develop as well. QBO was in the easterly phase. However, it was closer to the solar minimum in this case. In terms of extreme events that occurred in these top 5 years, 1893 to 94, there was a short cold snap in early January with 1.2 inches of snow at PDX, or downtown Portland, excuse me, with another 3 inches later in the month in a more marginal setup. 5 inches of more marginal snow occurred in February, followed by a late season cold snap with another 5 inches. This cold snap's pretty interesting because there was a sub-freezing high unusually late on the 20th. Now, we have experienced sub-freezing highs even later, as that occurred on February 23rd of 2023. Lows did stay in the 20s with one exception, which tells me that this was a likely east wind event. 1921 to 22. The November 1921 ice storm of the century occurred in the East Metro area / the Columbia Gorge. This had 6 inches of ice in spots, with 54 inches of snow reported in the Columbia River Gorge. If you are in the Portland metro area and you want to learn more about this storm in particular, I would encourage you to go to the November Oregon AMS meeting. Disclaimer, I am vice president of the Oregon AMS chapter, where this storm in particular will be discussed. The 54 inches of snow being reported in the gorge, that record still holds to this day as the most snow recorded in such a short period of time. There was also a December Arctic blast with 2 sub 30 degrees highs at Portland and 3 in Eugene. Lows did stay in the 20s, however. This was a likely east wind event as a result, and cloud cover was likely even on the dry days. 4.1 inches of snow occurred in Portland and 1.3 in Eugene, though I did notice some of that may have been sleet rather than snow. At the same time, I'm just going off of media reports from back in the day and trying to fill in the gaps with meteorological data, and it's not as complete back then as it was now of what type of precipitation it was. Mid-January cold snap with 2 sub-freezing highs, but there was only an inch of snow in downtown Portland. Eugene did have snow that month, but it was in more marginal setups. And then another late February dry and breezy cold snap. So far, looks like there could be multiple winter events. That trend continues with our more modern analog years. 1967 to 68, mid-December cold snap occurred with 4.8 inches of snow at PDX, though there were no sub-freezing highs. And Eugene missed out on this one. Late January cold snap also happened with 2 to 12 inches of snow valley-wide and a sub-freezing high. This was a rare case where Salem was the big winner out of a valley-wide snowstorm. Normally, it's either Portland sees a lot and South Valley's just in rain, or Eugene sees a lot and further up it's just flurries. For you warm weather lovers out there, I can report that it hit 70 degrees on February 28th. And then for the skiers and snowboarders out here, or anyone who cares about our water supply, yeah, this was not a good year. 60% of the average peak snow depth occurred that year. 2013-14 major Arctic blast and South Valley snowstorm occurred in early December with a negative 10 degree Fahrenheit temperature in Eugene, their second coldest all time. Second Arctic blast occurred in February with more widespread snow and ice. The season totals was about 16 inches in Eugene and 8 in Portland. There's absolutely nothing in between these two, though, so I like to call this a vanilla sandwich, with the bread being the best part of the sandwich. It was also a slow cascade snowstorm, though it did recover for a near average snow depth on April 1st. 2017-18 White Christmas occurred. Yeah, there was a little bit of a cold snap, high of 33 around then. Second cold snap occurred in February with more widespread snow, about 6.6 inches at PDX and about 2 inches in Eugene. Though, like 2013-14, absolutely nothing in between. This was also another year where we had a slow cascade snow start. It did recover again as we went later into the winter to, I believe it was slightly below average. I don't have that specific number in front of me. Right. Let's take a look at all of our analog year totals. Water year rainfall, we'll start at PDX. The top analog years are in purple. Rest of the analog years are in blue. The overall median was a little bit below normal at 35.37 inches. Top analog median came out even below that at 31.6 inches, though the weighted formula came out to be right about 35 inches again. And then just for reference, we had a little bit over 35 inches of rain last year in Portland. In Eugene, the analog median was 38 inches. Top analog median was lower, though, at 33.7 inches. The weighted analog formula came out the exact same. Eugene's average is about 4 inches more of rain compared to PDX. Temperature departures from average. The median's about half a degree below average, but the top analog median came out a little bit closer to average, with it only being about 2/10 of a degree below average. And then the weighted analog median came out to be 3/4 of a degree below average. Two main clusters that I see on this. The first is from about a degree and a half to 2 degrees below average, and the second is within a half a degree of average. Temperature departure from average in Eugene, a little bit of a larger trend towards the below normal side of things. The median was only, however, about 1/3 of a degree below average. Top analog median was further in the below average category at a degree and a half below average. And the weighted analog median came out to be about a degree below average. So as a result of taking a look at both of these, I'm more confident in predicting below average temperatures for Eugene than I am for Portland, especially when we're considering that for extreme events, I pretty much exclusively use top analog years, and with them all showing vanilla sandwiches, it's not a good sign for a confident prediction. Lowest wintertime temperature at PDX, 18 degrees is my all analog median. Top analog median comes out to be about 16 degrees, and the weighted analog median comes out also about 16 degrees. Lowest wintertime temperature in Eugene, the all analog median was 18 degrees. Top analog median was at 19 degrees. And the weighted analogs came out to be at 9 degrees, though, as you can see here, that was weighed down by 2013-14, which is the year that I thought was the closest to this year condition wise. For Eugene, that did have a 35% weighting um, in this chart here. So as a result, I have corrected that when I'm doing my final best estimates. Adjusted snowfall at PDX. I'm noticing not a lot of extreme years, though 2008, 2009, and 1945-50 did make the all analog year count. Neither were top analog years, though. All analog median came out to be about 5 inches, top analog median about 7 inches, and then the weighted analog median about 6 inches and change. The adjusted snowfall in Eugene came out to be about 3 inches, while the top analog median also came out to be 3 inches, and the weighted analog median also again skewed by 2013-14 to about 7 inches. A little bit more variety for Eugene overall, though still, well, not a lot in the extreme case. Also, as a side note, Eugene did not record snowfall between about 1996 and 2011. So as a result, there is no snowfall data anywhere in here. Not all of these are actually 0 inches. One other thing to note for Portland is there's not a lot of no snow years in the post 1940s where no snow years started to be recorded. Really, you just have one no snow year, and this is a 10th of an inch year. And most of the years here, there's a lot between that 2 to 8 inch criteria. Right, now on to our historically significant trends. First off, there has been 10 consecutive winters that have had measurable snowfall. This is a record high. Chance of 11th occurring if you disregard all analogs. 2.7%. Analog years do disagree with this, so I am leaning with the analogs as a result. Only 3 winters have produced a temperature under 20 degrees with less than an inch and a half of snow. All had 0 inches. Just because you have more than an inch and a half of snow does not guarantee a temperature under 20 degrees. However, that frequency is only about 60%, so not enough to just forecast that alone. There has been 5 winters in a row where the total days with snow on the ground have been above the median, which is 1.5 days. That is a record high. Chance of a sixth occurring if you disregard the analogs, 1.5%. One thing to note is that if we do get 2 days or more with snow on the ground, that would raise the median up to 2 days. So that would affect this statistic, though I've not run the numbers to figure out if that would bring it out of the statistically significant category or not. On the other end of the spectrum, there's been no deep Arctic blast for 11 winters. This is defined as negative 12 degrees Celsius at the 850 millibar pressure level over Salem. That is the pressure level that ranges between about 4 and 5,000 feet, depending on atmospheric conditions. And I chose that temperature specifically because if you descend an air parcel adiabatically in a perfectly dry environment, you will have the air parcel stay below freezing even when it reaches the surface. If you raise that to even just 11.5 degrees Celsius, you're above freezing once you hit the surface. Chance of a 12th occurring as a result is about 4.7% if you disregard the analogs. Correlations with past seasons. Second year Niñas almost always have a drier winter season. Questionable status of last year's census date does bring this into question. I'll still put it on here just to show it. This did occur 13 out of 14 times with back-to-back Niñas, which is a 93% frequency at PDX, and 12 out of 14 times in Eugene, an 86% of frequency. Last winter, we did have 14 inches of rain in the water year, in December, January, and February. This statistic does not apply the rest of the year, just December, January, and February. Now, let's get on to our predictions. I will start with the basics. First off, our water year. I'm predicting a near average water year with a total rainfall of anywhere about 30 to 38 inches, with 33 inches being my best estimate. Technically, that is about 4 inches below average. It'll feel very similar to what we experienced last year. South Valley, 33 to 42 inches, 37 inches is my best estimate. Temperature departure near to tilting below normal, well, up to 2.5 degrees below average. This is a low confidence prediction, especially for PDX. I'm again more confident in predicting this for Eugene. As a result, I'm not putting out a best estimate this year. Windstorms, I do expect a decent storm at some point. I didn't show windstorms on my extreme events this year just because there weren't anything that was like above 60 mile per hour, but there were a couple of windstorms that did get in this 50 to 60 mile per hour range, and enough consistency for me to bump it up from typical year to 50 to 60. Lowest temperature below 20 degrees Fahrenheit, best estimate being about 16 degrees. Could be a case where we have a east wind focused cold snap with just one night that gets into the teens. Most likely to be active, I do expect a double peak. That was a clear trend on the top analogs and did show up on the regular analogs too, though not as strongly. Most likely this will occur December and February. I feel far more confident about the February than I do about the December. At least one of these, however, will be less than a week. The other is up in the air, could be just a couple days, could be the entire month. We'll find out. In terms of the snowfall, let's start with the mountain snowfall department. Snow depth on April 1st, I'm expecting it to be between 70 and 110% of normal. The all analog median came out to be to be about 92% of normal, which happens to be my best estimate. And then for valley snowfall, 1 to 3 decent storms, net total of about 2 to 8 inches. PDX, my best estimate is 6 inches. And for our friends in the South Valley, my best estimate is 4 inches. Chance of a no snow winter does remain low this winter. I'm anticipating it to be about 20%. So that is it for this video. I do hope you enjoyed. If you do want to see the other presentations at the Winter Weather Conference, I am linking in that playlist in the description below as well. Otherwise, I will catch you all in the next video. Most likely there'll be a PNW Weather 101 episode in early to mid-November. So stay safe out there and take care.